Right, in this video we're looking at 7.2 number 6, and so we want to go through graphing a hyperbola. So the first thing that I notice is that it is for sure a hyperbola because it has a minus right between these two things that are squared. So it has a y squared and then the x squared. I also noticed that y squared is first, so that's going to be the more vertical hyperbola. So the first thing it says identify the center. So next to the x, because I want an x coordinate, is this plus 6. This is shifting to the left 6. So when I go to plot the center, I'm going to put negative 6. And then there's no number next to the y, so it's being centered kind of like 0, 0. So that y value is 0. It's not shifting up or down any. So let's check that part first. Perfect. All right. Now the vertices, it is going to be opening up and down because y squared is first. And so remember that the numbers underneath, so there's really, even though you can't see it, there's like a 1 underneath that y. So we're going up and down 1. So from this center, if we go up and down 1, that's going to be negative 6, 1. And then we're going to go down 1, so that would be negative 6, negative 1. And again, I know that it's going vertical, so that's why I'm only looking at that y squared. All right, to find the foci, remember we have the equation that c squared is equal to the a squared plus b squared. Also, we know that our hyperbola is going to open up to the foci, so I know that it's going to be negative 6 something, and it has to be bigger than this 1 here. So when I put in the a squared and b squared, really that's just talking about the numbers underneath. So under y squared, we have 1. And under x squared, we have 12. So we're going to take 1 plus 12, which makes 13. So c squared will equal that 13. So that would mean then that c is equal to the square root of 13. So again, from the center, I'm going to go up and down square root of 13. You do not have to approximate that. I mean, you could, to graph it, you need to know it's going to be a little bit bigger than 1. If you punch in your calculator, you should get 3, let's see, square root of 13. If it was a 9 underneath, then square root of 9 is 3, but it's a square root of 13, so it's going to be a little more than 3. But when I go and I actually punch in the number here, use the square root symbol. So I'm going to have negative 6, and then it will be a square root of 13, and then negative 6 minus that square root of 13. So don't put in an approximation here. Now for the asymptotes, remember that we're basically transforming the y equals x because we have like these diagonals and y equals negative x. So a lot of that is just going to be about thinking about the slope and the transformation. So I just pulled up a little whiteboard to help show that a little bit more. And actually, let me get to a grid here. So if we're at negative 6, 0, that's where our center point is going to be. And negative 6, 1, so up 1 space, this is counting by half. So up 1 would be right here. And then down 1, this is forming the box. And then I would have gone square root of 12 to the left and the right. And so to go to the, left and right, square root 12. So again, that's like 3 something. So if I go, there's 1, 2, 3, and then a little bit is what we're talking about. But just know that that distance is a square root of 12. That should be helpful. And then the same thing going the other way. Again, like 3 point something. So then a little bit more. But again, knowing that that distance that way is square root of 12. Again, that's forming our box. It's not the prettiest. I'm trying to draw this with a mouse here. And I realized I didn't draw my down 1 correct. So we'll fix that. Okay, and so we're just kind of going through making my box for my hyperbola. Okay, and so our vertices, again, we're at negative 6, 1, because again, this is going to be a height of 1. And then we went down 1. So that's where those came from. And then again, for the foci, it wanted us to, we're using that formula, the c squared equals y squared plus b squared. And so when we have that statement, if we wanted to plug in, we're talking about plugging in the 12 and the 1, because underneath are the a squareds and our b squared. So if we add 1 and 12 together, what we're getting right here then is going to be that c squared equals the square root of 12 plus 1, which is, oh, sorry, not the square root, yeah, it equals 13. So then c would have to be the square root of 13. Okay, so our focus, our graph is going to open up in this kind of direction. And so our focus has to be somewhere in here. It has to be a little bit past our vertex. That's where our focus is supposed to be. So it's going to go again up like square root of 13. So this distance from the center is a square root of 13. Okay, so it's really messy. Take that off. But you could kind of get the idea there. So remember, in order to even draw that part of a hyperbola, the thing that we wanted to draw was the asymptotes, and they have to go through the ends of our box like that. And then they'll extend for, like, they'll keep going that same path. I'm just going to draw that out in both directions here. But, I mean, they're going through the corners of our boxes and then go in the other direction. So you can see one's going to have a positive slope, and then one is going to have that negative slope. And what's supposed to happen is our hyperbola, these two branches, are supposed to follow the curve of those asymptotes. So again, it's not the prettiest, but I know I'm going to have to be in that center, and it's going to kind of cruise along the asymptote. So it's a very wide graph. And same thing on this other side. So we have two branches. But again, that's the idea. And my foci got deleted. So my focus is going to be somewhere up here. And the other one will be down here where it's opening up to that. Okay. So the last question that it wanted was to find the actual equation for those asymptotes. So what I was saying is that we're used to seeing an equation for a line, for the identity anyways, as y equals x. But we've moved, and we also have a slope. So let's think about the slope first. So if this had been at 0, 0 instead of negative 6, 0, if I asked you to find the rise, you'd say, oh, I went up 1. Okay, that was 1 whole unit. And let me try a different color here. So this distance right here, that's 1. And how much did I go over? I went over that square root of 12. So if I'm going to go back to thinking about my equation of a line, it would be y equals 1 over that square root of 12. Okay, so that's the slope, and then x. But we have been transformed. We've moved. So we can't just have that, but we have to take into account that whole left, right, up, down movement. Well, our y didn't move. We didn't go up or down any, but we went to the left 6. So to make that happen, I'm going to put x minus 6, just like we've seen before. When it's inside with your variable, it's switching it kind of the opposite of what you'd think. I'm sorry, not x minus 6, x plus 6, because that would make us go to the left 6. And a lot of that part you can get by looking back at your original. So if y had something added or subtracted, that's really what would happen here. So you can see this is the equation of a line that's been transformed. You can get fancier and put it in slope-intercept form, but it should accept it just like this. Again, no approximations for that square root of 12, so just write it in as is. So I'm going to write 1 over that square root of 12. And then I'm going to have x plus 6 and that should be in a parenthesis. Let's see. Okay, it's not accepting it as that, so it really wants me to put it in that slope-intercept form. So what that really means then, I'm trying to do it, it won't like it, is to just multiply that out. And so if I'm going to multiply that out, so it already says y equals, so that's awesome. So if y equals, it would be 1 over the square root of 12x plus, and then if you multiply 1 over square root of 12 times 6, it would just be 6 over that square root of 12. Okay. And so that's going to be the positive one. So let me enter that in here. 1 over that square root of 12. Again, that's x plus 6 over that square root of 12. So that's the first equation. Oops, and I dropped my x for some reason. Let me get that back. Okay, there we go. And so then the other thing that could happen is looking at it with that negative slope. So that's the other guy. And so that's putting a negative in the front. So let me change the color so we can see we're working with a different guy here. And if I put a negative in the front, if I'm going to distribute, that's going to get me y equals now negative 1 over that square root of 12 x, and then minus, again, you're distributing this negative 1 over square root of 12 to x, and then that times the 6 also, which makes a negative 6 over square root 12. Don't try and simplify that much. Like, nothing should really be happening with that. You can just leave it like that. Okay, so let's put that in here. So it's just negative 1 over the square root. Oops, I don't like to type that. Just use that symbol there. And then x minus 6 over that square root 12. Okay, so again, don't approximate, just put it in as is. And so when I check that, it worked perfectly there. So now to plot the graph of it, since I'm using the little graphing tool here, let's see what it says. So for hyperbola, it first wants me to place the center. So again, I know it's at negative 6, 0. So I'll put that, I'll mark that spot. Okay, and then it wants me to place the vertex. And it looks like actually as I'm doing this that point isn't very good. So I'm going to undo that and actually plot the point so that way it knows that it's going to be at negative 6, 0. Because it didn't look like it went on perfectly. Okay, so I got that point. I saw it grayed in there. We popped up. So there we go. It's at negative 6, 0. So when I go to that tool, it will be able to put it right on that point. And then again, for the vertex, we said the vertex goes up 1. So I'm going to, again, plot the point. And it was negative 6, 1. I'm going to plot that point, and I'm going to put negative 6, negative 1 on there also. And you can see it just drew those in there. I'm going to X out of that box. And again, finish the tool. So I'm going to plot that center, place the vertex. And then to make my asymptote, it needs to have another point to go to. So I'm going to go and think about, okay, if I'm going to be going from that point, negative 6, 0, I got to go up 1. And so I'm going to come over here and think about, okay, what's that going to be? If it's at negative 6, 0 and it goes up 1 space, that would be at negative 6, comma 1. But then it's going to go to the right square root of 12. So that's going to really add to that negative 6 a square root of 12. So let's see if that will work if I plot that point. Again, negative 6 plus the square root of 12. And then it had gone up 1, so I'm going to have that point plotted. So now that I have those points plotted, again, X out. Let's see if that's all the things I needed for this tool. So I click on Hyperbola again, place my center on the little X that they have there, place the vertex, and then place the asymptote. And it has all the parts there. You have to have used that square root of 12 with that plot pointing thing, otherwise it won't accept it. So let's check it. And it worked. So again, approximations will not work, and use that plot pointing tool. So that was helpful.